Hi there. So today I wanted to talk to you about GitHub and version control, and in particular I wanted to talk about how it relates to our studio and how we can use it as a collaborative workspace. So to start off, I'm just going to talk very briefly about GitHub and Git and why it's important and why we should use it. So GitHub is a form of version control, which is very similar to a lot of version control softwares that you probably already use, but you may not be aware of. So every time you might save your Word document and it keeps an old version that you're able to revert back to, that's a form of version control. Or if you use Google Documents, you might notice that they keep old versions of those files online. And what this is good for is a couple different reasons. Probably one of the largest is that it keeps files that you may have lost. You could have accidentally had that file deleted, you may have had a hard drive crash, and having these old files you can revert back to are really great for saving stuff you may have otherwise lost. These are also good to revert changes you may have caused problems with. Maybe you accidentally deleted something or broke something you're trying to fix. Part of the reason why Git was initially evolved was in the coding workspace, because people would create these applications and these softwares and then they would accidentally destroy them, and the best way to go back to them would be to revert to something through GitHub. The reason why it gets becoming more used in science is because it really improves collaboration. It allows us to share our information a little bit more easily and create more of an interactive workspace so that we can both do things together. It keeps a history of your actions, which in the post Jonathan Pruitt era is potentially relevant, because we have wanting to monitor what's happening to our data sets, what's happening to our code, and are there some, say, suspicious things that might be occurring. And so that's all to deal with illegal data manipulation or any type of just trying to keep a track record of everything that's happening to your code and your data set, so you can know what's either good or bad that's happening for it. So there's lots of different reasons why this is potentially useful, and I particularly like it because it provides an open, accessible workspace. It allows other people to use my code, use my analyses, and potentially do things that I've done in the past. Now, the way Git and GitHub work is Git is essentially a programming language. It's essentially not quite a programming language, but it kind of is. There's quite a specific syntax or a dialect that's associated with it, and it all falls under the GitHub umbrella. And GitHub is a website that keeps all of these codes. Here's what it looks like. This is what my dashboard looks like. And in here, you can find a lot of my repositories that I have set up. Some of them are private, some of them are publicly available, and what these are different projects that I'm working on, different analyses that I'm working on, and some of them have collaborators that are contributing their own analyses to it, that are contributing their own work to it, and some of them are just my own little projects that I'm working on that are all within my own workspace. So to start off, we're just going to really open up with how to set up a repository on GitHub. So if you already have an account, you've already gone through the process of signing your email and all that information. So now you're at the GitHub first page, and this is what your dashboard might look like. It'll look obviously a little different to you. You won't have certain things such as recent activity or lists of your repositories to access from. So the first thing we're going to do is just set up a repository, and you can click on it here. And it's going to bring you to a page like here. So all repositories are going to be bound by yourself because you were the owner. As such, they have this slash that you can give it a certain name, and this name can be anything because it's tied to you. So you can have the same repository name as somebody else because it doesn't have your name epithet at the beginning of it. So in this case, let's just call it practice example. And so I'm just calling it this to show what I'm trying to do. I usually put in a short description of what it is, so I'm introducing GitHub to those who might want to use it. There's two options here. I can make it either public or private. Once you've chosen one of these, you can always go back on it. So if you made a public repository, you can switch to private. Just know that during its period of time that was public, it was able to be copied and downloaded from anyone that they may have liked it. So typically, it might be in your best interest to start off as private and then rotate public. It is in particularly relevant for someone starting a research project who just downloaded all of their data and they want to keep it online and they don't want anyone to access all of their data. The next step is to initialize this repository with README. You really should add this. And then there's these two other things. It's the add, the git ignore. You don't really need to worry about that. RStudio tends to add that for you anyways. And then whether or not you want a license, again, it's not really something we come across quite often in science, but maybe something you'd like to consider, and you can read up more over there. So once you've created your repository, it looks something like this. It's going to have your README here, which you can add to as you go. It's going to have a list of files, which in this case is just your README, and has a bunch of other additional information here. It has your branch. So branches are different sub-sections of your code. This is more of a coding thing, less of a thing that might become more relevant for science, but branching is very important if you want to experiment and try doing different coding and different analyses without messing up your main analyses. This way you don't keep building a bunch of different script files and you don't risk damaging everything. But for the most part, I haven't really found a use for myself with branching, and so I'm not going to refer to them or for the rest of this tutorial. You have some other things here. You can create files, you can upload files, you can find files. In this case, you only have one file, so there isn't really much to find. Uploading files works quite easily. You can just drag and drop files in here as if you were using Google, like a Google Drive. And then what I'd like to first show off is how we'd create a new file. So when you create a new file, there's a certain cadence that needs to occur, a certain series of actions that you need to do to actually have your file go online. So the first thing is you have to name your file. This is the same as if you were making a file anywhere else. So I'm just going to call it test. I'm going to add some new text into my file. I'm trying this GitHub thing out. And the thing that makes this a little different than other softwares is that you need to commit it by providing some information. And so here you're adding in some form of information towards what you've done here while you're creating this file. This would be the same as if you were uploading a file, if you were updating a file. Anything to do with making changes to GitHub, you do have to provide a commit message. And in this case, I'm going to put I'm adding a new file. Or how about I'm adding my first. And it gives you options about the master branch or a new branch, but in this case we're going to keep it simple and attach it to the master branch. So when you do that, it provides you with a little bit of information. It provides you, now we have that file that's been generated, we have the commit message, which could come in handy when you're trying to keep track of where did this file come from, what was the last thing I was working on with it, etc. And also provides a commit code so that you're able to revert back. So let's say I didn't like this, I want to delete it, I can reverse this commit, which I'll show a little bit later on, and you can end up deleting this file. Conversely, this could help you keep track of things in case you wanted to move forward. And you're saying, okay, where did I leave off? What was the last thing I was working on? It keeps the timestamp of when it was last worked on, it keeps some information, keeps the name of the file, and this really comes in handy trying to keep track of everything. There's a lot of information associated with GitHub. I'm not going to go through a lot of them. I'm just going to highlight a couple. So the first I'm going to highlight is issues. Issues are quite fantastic if you are in more of a collaborative workspace. So let's say I saw that someone put that file there and I wanted to provide an issue. I might name that file, so the test file. So what I'm doing here is I'm generating an issue, and this issue gets assigned to the project. And now that I submit this issue, the owner of this repository will now have this open thing that they need to edit. They can either address it by responding to it to get some more feedback. They could close the issue if they think it's either been resolved already through their own discussion, or they choose to resolve it themselves. But right now, this is an open, outstanding issue that's available. And the reason why issues sometimes are advantageous is because it allows people to communicate back and forth on their projects in kind of a confined workspace without having to send emails back and forth. This way, you're not looking at old emails to try and find out what was the last thing this person suggested I do, what was the last analysis this person suggested I try and do. Instead, all they have to do is click on this issue, see where they left off, whether or not it had been addressed, is it open, is it closed, and move on from there. Now I'm going to pan over to the settings, which has a bit of information going on here. So it has some generic stuff, such as the template name, which you're able to rename. You can provide some additional information that you want associated with it. I'm going to pan down a little bit, and one of the things we tend to use a lot here is GitHub Pages. So what GitHub Pages is, it allows you to host a website within your GitHub repository. And that website that gets allowed is usually an index.html, which becomes more relevant when we get into the R workspace, but for now perhaps isn't as relevant. The one thing I do want to highlight though is you don't necessarily need to do this, but I tend to turn it on, so instead of setting which page I want to be my master branch, which one do I want to be available online, I'm going to click my master branch, it's going to reload, and then when I go back here it's going to say I have this website that's hosted online. So I'm going to copy and paste this URL because it becomes relevant later on. Now there's 4 other danger zones that I'm going to look at over here, so make this repository private. If I wanted to take it off GitHub, I can transfer ownership, which has its own inherent problems because if you transfer it, you're not able to get it back. You can archive this repository, which essentially means it becomes read-only. You can no longer make edits to it, you can no longer add commits to it, or you can delete these repositories. So each of these 4 have their own quite substantial impact on your repository, and to do any changes to them, you usually have to put in your password again, and also write out the name of the repository. Since we don't want to delete it just yet, oops, I deleted, went too far back. Here is our workspace once more. I'm going to click over here to the website, and I'm going to paste in my website, which is called Practice Example. So now this repository is hosted online at this URL. If I were to click on it, it's going to bring me to this, which right now is just the README file. We can develop this a little bit more, but we're not going to develop it just yet. So that's a brief overview of what GitHub is, what GitHub looks like online. You can do all of your work in this workspace, but really the power that comes through GitHub is its ability to integrate with RStudio, and that's what really makes it useful, is trying to collaborate and provide information and add data and all that stuff. So now that we got this, we're going to rotate over to RStudio. Now to do that, you have to clone your repository. So what this is doing is it's taking the URL that's associated with your repository. We're going to bring it over to your RStudio, and you're going to say, build this repository on my RStudio workspace. So I'm going to bring up RStudio here. To do it in RStudio, you click on File, you click on New Project, and just wait a second before it brings up. You'll have an option for version control. You want to tap on that. You're going to tap on Git, and then it's going to say repository URL. That's where you're going to paste in that name. It's a good practice to keep the project directory name the same as the repository name, so I just leave it like that, and you can assign it to be generated in whatever subdirectory you'd like. When I create this, it's going to clone the repository into my RStudio workspace. And here's what you're normally accustomed to when you first generate a project in R. So we have our usual panels. You notice that that test file popped up, and so it's available to us as well. So anything that's available on the R workspace is now available online. And you also have this new tab here, which is called Git, which you probably didn't have before. So RStudio generated that gitignore file that I was talking about earlier, and has also created an R project file. The reason why these two files populated into this top panel is saying that there's been modifications to the repository that occurs in your computer but that aren't present on your online database. So because RStudio generated this R project file, because it generated the gitignore, these two files are now different than what we had online, and so Git and this Git tab in RStudio is essentially indicating to us, hey, there's these two differences, what would you like to do with them? Now before we go into that a little bit more, I'm going to generate an RMD file. So we go into New File, and we're going to do R Markdown. It's going to ask you what the title is. It does make sense to call it index, and the reason why is because that's how you end up populating your website. So it creates this mock data set here, which I'll talk about in a second. But again, to keep maintaining practices, we should also save this file. And again, we want to save it index. The reason why it has to be saved index is because, for those of you that are a little familiar with website design, index is what search engines and websites look for when you go onto someone's particular web page, and so index tends to be the main web page, and if the file is named something else besides index.html, it doesn't get indexed properly online. So having that term index spelled exactly the way it is, all lowercase, that is really important. So an RMD file is initially a little bit daunting, but it's actually quite easy to understand. It's really two parts. It has the markdown syntax and it has the R syntax. And what markdown is, it's really a simplified version of HTML. It was generated by a couple of great researchers. I can't remember their names off the top of my head, sorry. But what they were able to do is kind of consolidate a lot of the information that were normally present in HTML into something a little bit simpler. So for example, this double hashtag represents that this should be represented as a header. If that were to be in HTML, what that would look like would be something like h2, r markdown, and then you'd have to comment out the header call. So it tends to be a little bit more complicated, and it gets considerably more complicated as you go along. So markdown, it does have its advantages for that. If you go under tools, under help, there should be some cheat sheets, and there's a cheat sheet here actually on how to use R markdown. And it provides information on all the different things that you could do in Markdown, all the different syntaxes. It gives you a list on the left here of how to turn things, what things would look like in Markdown and how they end up turning into regular text. Again, this cheat sheet is quite daunting. You probably don't necessarily need it, but it is something you might refer to try and find certain things as you move along, or you could always just search for it on Statistics Exchange or something like that. So we set up our Markdown file. This again is just a template that's available online. It uses the cars data set that we see online. And the second component of the Markdown, which is beyond the website component, is the fact that you're able to do R code in here. So here, what these three accents are generating is a chunk. And what this chunk is doing is it allows R code to run inside here. So this different coloration band, this slightly gray versus the black, shows that the black is within the Markdown environment, the gray is within the R environment. So everything in the space will run as if it was regular R code, and everything above will run as if it was HTML code. So when I click knit, it's going to run this entire website, top to bottom, and then produce the output that looks associated with it. So let's see what that looks like. Great. So we have the name of our site, the name of our file, which in this case is called index. It has the name of myself. It has the date that it was generated. You can add these if you'd like. It has the markdown text. You'll notice that this text here is much larger, and that's because if we go back here, it has a double hashtag representing a header. We have regular text that's represented. We have a link that again is represented here. And we have that R chunk that gets worked up, and it has things such as generating a plot. So let's go through another example. So we have cars. Cars dataset's embedded into R, so it's always available. And remembering from the cars dataset, it usually has two things. It has speed versus distance. Let's try doing just a linear model. So I have model 1, linear model. I'm going to do distance is affected by the speed of the car. Forgot to call in the data frame. So data equals cars. So I run my linear model. I'm running it just from the command prompt here, as if you would do normally in RStudio, and then I can get the output of that model. When I do that, I get all the statistics that are associated with it. So now if I knit this, I should see all of those results available here too. And I do. I see them all present here. And part of the reason why this can be advantageous is because it allows us to provide some comments. So I'm going to remove this chunk and generate a new chunk here just by typing it out. You can also insert chunks yourself if you don't want to go through all that work here. So if you click here and then insert our chunk, it does that whole syntax for you if you don't want to be bothered. And then I'm going to add a new comment saying running linear. And then after I've run it, I might add something like, oh, I noticed that it's quite significant. So I might say that speed significantly predicts distance be less than 0.0. And if I wanted to bold it, some of the syntax in Markdown is just using asterisks. So now that text would be bolded. So I have my new heading here where I said I ran the linear model. I have the output from the model that's all being run in R, and it'll run every time that I click in it. And then it has my comment here at the end that speed significantly predicts distance with a p-value, and that p-value is now highlighted in bold. So now that's kind of the nice thing about generating these. You can generate these nice reports that work in HTML, but now I want to push all this information online. And that's where it gets a little bit tricky. So we have these new files here. We have the same two from before, the gitignore and the practice, but now we also have these two additional files that we've generated, the RMD file and the HTML file. And what's being highlighted here is that these files have been modified, they've been new, and they are not represented in the online workspace. So what you want to do is you want to click on commit, and it's going to bring you to a page like this. And what this page does, it allows you to review changes that are associated with each of the files. Now, we don't really have any changes in this bottom space. So in this bottom space, normally you would see the difference between what was and what is, but we don't have that right now because we haven't made these files before. So all we see is a giant white space. I'm going to click Stage, and staging is really just like selecting something. It doesn't mean anything beyond that. It's as if you were just highlighting it. And the reason why staging is a step that's necessary is because you might not necessarily want to push all of these things online. Perhaps you want to move some, but not everything, and that's why they're not all moving online. So we see at the bottom space some of these files have populated. The green means that stuff's been added, the red stuff means stuff's been deleted. Nothing's been deleted because these are all brand new files, and so we only see green. And again, we need that commit message. So I'm going to say setting up repository. And I'm going to commit that message. So what you've done now is you've essentially primed your change. You found the change, you selected the change, you've committed them, so now they're available to go online, and then the final step here is just to push it online. It's a one-directional sync that occurs through RStudio and GitHub. So it's a little different than something you might use on an Apple product. It's only one-directional, and what that means is that I've pushed it online, but it's not the same as pulling anything new. So there's two options here. You can push, you can pull. Pull means bring the stuff offline, online. Push means bring the stuff online, offline, online. So let me go through an example to make that a little bit clearer. But first, let's see if our files actually made it online. So we've pushed them, and if everything went well, they now should be represented here. So I'm going to refresh this web page, and here we are. We have our files. We have the indication of them. In this case, they were set up 1 minute ago, and it should be working. Now, sometimes the website takes a little bit longer to populate, but let's give it a shot. Perfect. So this is our index file that we were working on, and now it's hosted properly on our website online. Now, let's say I go here and I make an edit. So I'm editing this text file that I created. Test. Making some changes. Should be a little bit more informative than that. Updating test file for full example. You should try to be a little bit more informative. It's very tempting to try and keep it brief and dismissive, but it can really help you down the road to have commit messages that are at least somewhat descriptive to keep track of the stuff that you've done. So we've committed those changes. and now they should be populated online. And if we go back to our repository, we can see that our test file has been updated. If I want that to be represented here, I'm going to click pull, and it's going to now move that file onto my computer. So now if I look here, test, this new file is represented again. Now let's say I want to do a change here. Let's say I want to delete this part because it's not really relevant to what we're talking about. So I save it. I've generated a new HTML file. That part is at the bottom is now gone again. And you'll see there's been two edits. There's the RMD file that I saved, that I deleted, and the index and the HTML file that was generated from that knitting process. The M represents modified. So if I click commit, we're going to see the files here again. I'm going to click stage, which says I want to push both of these available online. If I look at each of these files, we'll notice that there's a red section, and that's a red section that's now deleted. And I'm going to say I removed parts unit on. Again, we're going to commit that, close, push, and now we're sending everything back online again. And in a few seconds, it should be all represented there online. So go back. Perfect. So it's really just going back and forth. You pass it. You can pass it to the GitHub. GitHub passes it back to you. And where it becomes particularly collaborative is that now you can add collaborators to this, and they can do the same thing, and they can make changes and edits and add analyses, and then you can follow suit and do the same thing. You can add data sets. It doesn't need to be just code. You can add folders. Anything that falls under your GitHub architecture here, in this RStudio architecture here, literally any file you can put in here will be allowed to be pushed online. The only restrictions that they allow is that files that are above 50 megabytes typically give a warning, and files above 100 megabytes have additional requirements because GitHub really doesn't have unlimited resources for storing all of your stuff. So there is some kind of space requirements in that aspect, but with small files, a lot of like coding files, text files, it's pretty practically unlimited, all the stuff you can put online. And that tends to fulfill most of our purposes as scientists. Now, good practices, every time you open up our workspace and you're ready to work on this project, it's really a good idea to pull, because you don't know if your collaborator was working on something when you weren't, and there's a potential that you might have a conflict. A conflict occurs when you have made a change and someone else made a change at the same point, and now they are trying to overlap with one another. The good news is that it tends to be easily fixable. The way GitHub and RStudio work is that you have to really edit the exact same line at the exact same time for this conflict to occur. And I'm going to go through an example of what that might look like. So let's say I click on my text. I'm going to delete this text part and say new stuff, removed text, remove the test part. So I've committed that change. And if I go to my test file here, I haven't pulled yet. So these changes have not been represented. So I'm going to delete the same line. If it was a different line, it wouldn't show a conflict. But because I'm deleting the same line, it's going to be an issue. I'm going to add another test. I'm going to save that file. I'm going to try and commit this file. Added a test. It's going to allow me to commit it because it doesn't know anything is wrong, but when I push it online, it's likely going to give me an issue. And it does. It says that something is new online, that it isn't represented on my computer's workspace, so I need to pull first. So let me try pulling. And now it gives me merge conflict. So it's going to tell me to go look at the merge conflict, and the merge conflict looks like this. It has this head part, which shows what you've done, and then it has these dashed lines that represent what's been changed. And it's really up to you to decide what you want to edit here. You'll notice that it's confined just to the areas that were actually affected. So those previous lines would actually be all safe, and you don't need to worry about them. Well, I've decided that I want to keep the new stuff. I don't want to keep the old stuff. So then I'm going to go back. I'm going to recommit this I'm going to add that I fixed the conflict, and then I'm going to commit this message. And now, when I push, everything's good again. Now there's two more features I would like to show. So the first is that Git also works off of a command line prompt. You can access it by clicking on the settings button and then execute shell. This might not come in handy very often, but it does tend to come in handy for some uses. The command line allows for a lot more flexibility than the GUI interface that's associated with RStudio. You typically don't need to kind of come into this space until you're dealing with some problems, such as oversized files or trying to remove a commit. And removing a commit can be quite challenging. I'm going to try and show an example of why we do want to do that. So sometimes you may have made a mistake. Let's say I actually wanted to keep some of that stuff that I deleted. What you would do here maybe is do a git reset. So you're typing out that you want to revise some of those commits that you've just previously done. And I'm going to do a soft commit, which means I'm only removing the commit. I'm not actually deleting any of the files. Everything's going to be back to the way it was, just not pushed online. And I'm going to do head ~1. And what this means is go back one commit, but don't change any of my actual code, don't change any of my files, just remove the commit as it was. Oops, I forgot the second dash. So when I exit this, it's going to repopulate that test. So it's as if I never pushed it online. But I'm going to say that I still want this online. Commit again, commit, and then push. So this tends to happen if I wanted to remove that stuff that I had done entirely, then what I would have done is done a hard commit. It's just it's giving me an error message only because I pushed that file already, and so now I'm pushing it back onto itself, and it's saying that the file that I'm pushing is the same as what's already represented. But all of that should be fine. And so that's how you'd access your console, and that's really how you'd access your command line for GitHub, and that could come in handy for doing anything above and beyond what you'd expect on your day-to-day activities. But for most intents and purposes, everything you'd want is all found within this tab here, and everything you would do in R you would normally do here. The only difference is that afterwards you push it online to allow someone else to work on it as well. Now the final thing I want to show you is how to add collaborators. So to do that, you do want to click on contributors. Oops. I actually can't remember exactly how to add contributors. It's under settings, I believe. Manage access, edit my password. And you can invite a collaborator this way. And you can either add them by their username in GitHub, either by their full name or by their email. Once you've provided that information, they will now have access to the GitHub, to that repository exactly the same as you, and they're able to analyze things exactly the same as you. And this is really where you start opening up the possibility of you editing things, they editing things, and you can work back and forth in this iterative process to pass everything online. So just a quick recap. RStudio is the same as it always is. It just allows this opportunity to work more collaboratively with people online. The first thing you do when you actually start your project is you should always do a pull to make sure that your repository that you have in front of you and all the data you have in front of you is up to date with what's available online. Then you should work as hard as you like to work, as you normally do, and then at the end you want to stage commit and push all that information online. And from there, you should be good to go. Well, thank you very much. I hope you guys found this informative, and if you have any questions, feel free to reach out to me. My information should be in the description below, and I appreciate you watching my video.